G'day everyone and welcome back to the shop and welcome back to part 2 of this little small 4-stroke engine build. Now last week I left you off where we got up to this stage where I drilled and tapped the holes, fitted the bearings and of course assembled the bottom end, or assembled the frames for the bottom end. So in this week's video, part 2, we're going to be taking a look at the crankshafts and putting the dividing head onto my milling table and milling the keyway slots in both of these. Now I didn't capture this on camera, but what I did here was then use a 12mm ream and just very delicately run that with my hand through here, just so the dowel pin, the 12mm dowel pin, would go in. Now they've been Loctited, they've been sitting now for a couple of days, so they're on there really good, really tight. Also in the video today we're going to cover making the bronze bushes for the connecting rod, and I'll talk about the little mistake that I did when making this, which is a trap for young players, and we'll talk about that more during the video. What I did, I made a little fixture plate that when I reamed this one here, I put a dowel pin inside, made sure it's perpendicular, and then I reamed that one here. Now, I'm a little bit disappointed in my ream, and look, it's my fault because I was too greedy. I tried to take off too much of the ream and run the risk of blowing the hole out of size. So the hole is blown out a little bit. I'll probably re-bush that down the track. I'm not going to worry about it at the moment because I'm going to keep moving forward. So once we'll do these keyways, we'll also do the keyways inside over here, the keyway for the camshaft. No. I've brought you back onto the mill here, and what I'm currently trying to do is that I'm trying to ream this little end bearing so it's perpendicular to the big end bearing. Now, when I made these con rods, I made the fatal mistake of using bright mild steel. Now, bright mild steel, as soon as I've machined it, has actually bowed like a banana, so trap for young players. Anyway, never fear, my Chinese reamer's here, and I'm going to ream that now and get that on size. You can see the dowel pin in here. I've set it up here. It's exactly 83 millimeters. It's on the center line. I've got the digital readout clocked in. So let's ream that hole. Now that ream is running a little fast. So currently I've got the dividing head on the table, and I've set it up so it's true in the Z plane and in the X axis plane. And of course I've dropped in here and I've found the center of my crankshaft, and I'm putting the keyways in. Alright, now referring back to the black book for this, so I know the depth of my key set, and it recommends a 5mm key on a shaft this size. So I've taken a photo here of the black book, and I'm looking around here between a crankshaft diameter, or of a shaft diameter between 12mm, over 12mm but under 17mm, and that's what I'm on. Mine's 15mm here. It says I need to use a 5x5 key, and my depth in there, the set, is between 3 and 3.1. Right, so if we come back here, you can have a look at the photo. That's the this H, the uppercase letter H, so that should be 3mm from the top of that crank. Now with the keyway, so this is a feather key that I've got to install in here. I need to be 4mm in from the end, and then the keyway itself is 25mm, so I'm using a 5mm end mill here. Now usually I wouldn't do that. I'd use a 4mm end mill and walk it in, so cut up the center, then take 1/2mm off the back edge, 1/2mm off the front edge, and then check with gauge blocks to make sure that I'm right. For this little job, I'm not bothering with that. Right? As I was feeding this, I was ramping down. All right, so instead of plunging down, I was auto feeding and ramping down, which is a lot easier on the end mill, and that's what you do in a CNC application as well. So with being a 5mm end mill and a slot of 25, so my overall slot length now is 20 on my DRO. So let's start it up and let's cut this here. And I'm just doing some simple keyways here at the moment. And this is a 4mm keyway, and I looked up in the black book, so the depth of this key should be 2.5 for a 4mm keyway. The tolerance is 0.1, so 2.5 to 2.6. I'm using a high-speed steel slotting end mill here from Sutton Tools, which is a coated end mill, by the way. So I've got it on the center line, and I'm just going up, putting in a feather key about 16mm long. I've got the cam lobe set up in the mill vise, so I've actually dropped in with my edge finder and found the centre of the cam lobe, like this, like so. And once I found the centre, I came in 4mm off that back face. And what I'm going to do here is to spot drill and tap a little 4mm hole for a grub screw, and then I'll rotate the cam lobe 90 degrees and drill another one there. So that way then I've got 2 grub screws on that cam lobe. Now I was thinking of using some brazing rods and brazing this onto the camshaft, but look, I'll just stick to the design that Sander Vercammen did and just use 2 grub screws to hold in there. It should be right, I think. Famous last words. But anyway, let's give it a crack. .3 Sutton high-speed steel drill bit. You'll notice I just went a little bit deeper with that spot drill to give me a bit of a chamfer. There you go, we're through. Now this is a ISCAR high-speed steel tap, but it's designed for my CNC machine, so it's designed for rigid tapping. So as it taps, it will pull the swarf out through the top. Put some Treflex on that. Now I put the tap back in just to hold it, and that way then I can come in from this side here now and get that pretty much vertical. There's our 2 M4 holes drilled and tap, and these can actually go onto the camshaft now. One inlet and one exhaust cam lobe. Now the camshaft is just 12mm ground steel. Now I got that off AliExpress, and I think they sell that stuff as to do CNC, routers and stuff like that. So there's the shaft there. Now what I've done off camera, I made a spacer or an end cap that goes over that shaft, and that will encapsulate a little bit of that end shaft and a 6mm bolt cup, and that will stop that shaft getting pulled out. Now I've also, once that goes in, we can slide our cam lobes on here. Now you can see I've got the grub screws in here, but they're way too long, so I've ordered some new ones. They're 10mm, well they're 4mm 10mm long grub screws. I've ordered some 5mm ones, so that will just do a little bit of stick out, but these ones nearly hit the crankshaft, so they've got to go. And once I can do that, I can set up my valve, so when the piston is at top dead center, both valves should be on the rock, what we call valve overlap, so I'll be able to adjust that later. Now on the other side here, I've made a little spacer, a 3mm spacer, and machined that on lathe, then surface ground it so I could get it precise, and that goes over here. Now these are, like I told you in the other video, these are just 3D printed gears. We will cut some proper gears, but I wouldn't mind trying these to see if it actually run. Now this motor's not going to run, it's not going to power anything. It's designed to be a stationary engine to start it up on the bench, and so these might actually work. So I'm curious to see if that will work.